Okay, so let's dive into the science behind the 2025 Nobel Prize in Physiology or Medicine. It's all about something called peripheral immune tolerance.
Right, a really groundbreaking area.
Definitely.
Yeah.
But it's also caused a bit of a stir online, hasn't it? We saw this claim floating around, something like, this means cancer will be cured in 20 years.
Exactly. And that kind of oversimplification is, well, it's what we really need to talk about today. Our goal here is first, let's unpack the actual science, how our immune system learns not to attack itself.
Immune tolerance, yeah.
And second, use this Nobel discovery to, promote some critical thinking about how we react to big medical news. We want to explain this complex stuff simply, no PhD required.
Good. Because understanding that control, that check and balance you mentioned, feels like the key. So the prize itself went to Shimon Sakaguchi, Mary Brunkow, and Fred Ramsdell.
For their discoveries concerning peripheral immune tolerance.
And this tackled a really old problem in immunology, right? For over a century, scientists wondered, how does the immune system fight off germs, but leave our own organs alone? Your pancreas, your nerves.
Precisely. How does it tolerate self? We already knew about something called central tolerance. That happens in the thymus. It's like basic training, where T cells that attack self are mostly deleted.
Mostly.
Yeah, mostly. Some always slip through the net. They escape. So we always suspected there had to be another mechanism, out in the field, outside the thymus, to keep these rogue cells in check. Peripheral tolerance.
Yep. Okay, so who are the police out in the field then? This is where Sakaguchi's work comes in. Back in 1995, he identified a specific kind of T cell.
He did. It was a landmark experiment, really. His team took healthy mice and removed just this one subset of T cells, CD4 positive, CD25 positive cells.
And what happened?
Well, the mice developed all sorts of autoimmune diseases, like their own bodies were attacking themselves everywhere. But then, crucially, when they put those same cells back into the mice,
The attack stopped.
the attacks stopped. It proved these cells weren't just passive, they were actively suppressing the immune response. We now call them regulatory T cells, or TREGs. They're the main players in peripheral immune tolerance.
So TREGs are the peacekeepers, stopping the immune system from causing, like, internal friendly fire.
Yeah.
But if they're suppressing things, couldn't that be tricky if you're trying to fight something like, say, cancer?
You've hit on the critical point. It's all about control, and the control mechanism for these peacekeepers. That came a bit later, around 2001. Brunkow and Ramsdell were studying mice with a really nasty autoimmune disease. They called them scurfy mice.
Scurfy mice.
Yeah, not a great name, but a descriptive one. They found the disease was caused by a mutation in a single gene. They named it FOXP3.
Just one gene messing up caused this huge immune meltdown.
Exactly. It showed FOXP3 was essential for maintaining self-control. Then, a couple of years later, Sakaguchi's group put it all together. They showed that FOXP3 is basically the master switch, the transcription factor that controls how TREG cells develop and work.
So FOXP3 builds and directs the TREGs. And if FOXP3 is broken,
Then you don't get functional TREGs, and the immune system runs wild. That's why mutations cause such severe autoimmune diseases, both in mice and in humans. It's the loss of that crucial off switch.
okay, this brings us right back to that cancer claim. If TREGs are suppressors, controlled by FOXP3, doesn't that completely undermine the simple idea that we just need to boost our immunity to beat cancer?
It absolutely does. It highlights this incredibly delicate balance, the immune system in cancer. It's
Yes.
complicated. It can be a savior, hunting down cancer cells. But TREG cells can actually protect the tumor by suppressing the immune attack against it.
So they can become accomplices.
In a way, yes. So just trying to enhance immunity, maybe with supplements or whatever, without considering this regulatory side. It's not just simplistic, it could potentially be harmful. You might accidentally help the cancer hide, or even trigger autoimmunity.
So the real goal isn't just a stronger immune system, but a balanced one. Normalcy is more important than raw power.
That's the perfect way to put it. Normalcy. Balance. This Nobel Prize is a testament to that complexity. Effective defense absolutely requires equally effective control. The future isn't just about turning the volume up, it's about tuning the system precisely.
Right, so if it's not a magic cancer cure in 20 years, what are the real-world benefits we can expect from understanding TREGs and FOXP3 better?
Oh, the potential is still immense. Think about treating autoimmune diseases, conditions like type 1 diabetes, rheumatoid arthritis, lupus. If we can manipulate TREGs carefully, we might dampen those self-attacks. Also, organ transplants boosting TREG function could help prevent rejection.
And for cancer?
For cancer, it's about selectively targeting TREGs within the tumor, Not system-wide suppression, but finding ways to lift the brakes just around the cancer cells, making current immunotherapies work better for more people. It's about improving existing treatments, making them more effective.
So it's a huge scientific step. Confirming the immune system is this intricate, balanced system, not just an on-off switch. But that initial hype, the cure in 20 years, just misses all that crucial nuance, doesn't it? The need for control.
Completely. It's a victory for understanding regulation, not just brute force activation.
So maybe the thought to leave everyone with is this. Given how delicate this immune balance is, how controlled by things like FOXP3, what assumptions are you making when you hear health claims that only promise enhancement or boosting without ever mentioning the need for control?
Mm-hmm. Something definitely worth considering next time a simple health fix sounds a little too good to be true.